Hi all, we're going to look at some quadratics that have the variable appear more than once. So you can tell you're looking at, let's make sure we're clear on this. Linear equations, the variable never has a power of any sort on it. It's never in the bottom of a fraction. It's never under a root. Rational equations, you generally will have a variable in the bottom of a fraction. That's kind of the distinguishing thing. So ugly fractions with variables in the bottom and maybe in the top as well, but particularly in the bottom. For quadratic equations, you will see powers on your variable, but they should only be first or second powers. You won't see anything higher than second for quadratic. So those can actually be really tricky because there's no way to combine an a squared and an a, so getting down to just one of your variable is hard. So what you'll see in this section is just some kind of specially built ones. There are special cases where they actually turn back into linear equations. So we're still kind of stuck on a lot of quadratics, but we'll tackle what we can. So the tools of this section: free your variable from any mess, fractions, parentheses, radicals, move it to one side, hopefully combine to a single variable, and then reverse order of operations. Here, the big thing I see, well, I am kind of worried about this second power hook to my a because that means I can't combine that with the single a. But otherwise, the only thing I see going on, what the heck did I make? Hold on. I've been making terrible questions. Let's say black. There's a 6 out in front. Ooh, hold on, let me think about it. No, I changed my mind. I didn't make a bad question. I was second-guessing myself. I see how it'll work. Okay, so we're going to distribute through to free the a from the parentheses. So we'll get 6a squared plus a minus 2 equals a squared plus a. Okay, so I actually lied. I said they all have to turn back into linear. They don't. This is another thing that would work for us. So right now I'm saying, okay, well, I need my variable all on one side, so it doesn't matter which way. Let's go ahead and move it this way. I will subtract the a squared, 6a squareds from both sides. You can do this all at once, but I'm going to do it in two pieces. So there's no a squareds left on the left, but there is an a minus 2. On the right, there's a negative 5a squared, and there's a plus a. And then I need to move the a as well, so all of your a's need to go on the same side. So if you want to do that all in one step, fine. This is where I get saved a little bit. I have negative 2 on the left-hand side, and I have negative 5a squared on the right-hand side, but my a's went away, which is a relief because if I couldn't get down to a single a, I'm stuck with the methods that we have right now. So looking at this, what's happening to my a? If I plugged a number in, I would first square it and then multiply by negative 5, which means to solve, I'm going to first get rid of the negative 5 by dividing. And I get 2/5 is equal to a squared. And then I want to get rid of that second power. So the second power, to get rid of that, you would need a square root. But we need to be really careful. Remember, there are always two things that you could have squared to get 2/5. There's a positive number and there's a negative number. So if you introduce a square root, it needs a plus or minus. This is so important over and over and over again. So what I get is a is equal to plus or minus the square root of 2/5. I'm actually pretty happy with that answer, but we're trying to practice our work with roots, so we'll go ahead and rationalize the denominator. Remember that this is the same as root 2 over root 5. So if we don't want radicals in the bottom, we'll just multiply top and bottom by root 5, and we will get root 10 over root 25, which is 5. And that would be my final answer, except I don't want to drop that plus or minus. Plus or minus root 10 over 5. Okay, so kind of special cases that we can work with now, but that still does give us some interesting things to solve. Let's look at the second one. Okay, so 4 times a minus 6 squared equals 12 times a minus 6 squared. This is kind of a funny one because I think it's really tempting to say, okay, I'm going to get rid of the parentheses by multiplying a minus 6 times a minus 6. Some people are tempted to just distribute the square. Don't do that, that's bad. But I actually don't even want to FOIL it out. What I want to do is say, well, I actually kind of like that as it's written, instead of having a squareds and a's floating around, I just have the a's, the a by the 6's, but still. I don't have 2 powers of a showing up in the equation right now. So what I'm actually going to do, it's a little bit tricky. I'm going to say, okay, well, one way to get my variable, so this is a little bit diverging from our usual trick. One way to get my variable isolated on one side is just to notice that those are actually like terms, a minus 6 squared and a minus 6 squared. So if I have 4 of them and I take away 1, I'm going to end up with 3 a minus 6 squareds. And all that's left on the left-hand side, or the right-hand side, I keep doing that backwards, don't mind me and my left-right, is a 12. So this one might seem weird because it doesn't, maybe that doesn't feel like it fits our clear the mess. What I would say is this is one of those spot the easier problem mixed up in the mess. So kind of like in the last one, we ended up with a squareds on both sides and we moved that over and combined. That's really the same thing we're doing here, even though it's an a minus 6 squared. Okay, so now what am I doing to a? I'm subtracting 6, I'm squaring, and then I'm multiplying by 3, which means I need to divide by 3. So a minus 6 squared is equal to 4. I need to get rid of the square next, so I'm going to square root both sides, but remember there are 2 things that you can square to get 4, and those things are plus or minus 2. And then last step, I need to add 6 to both sides. Plus 6, oh my goodness. And I get a equals, and it doesn't matter whether you write the 6 first or last, but 6 plus or minus 2. And that's a nice condensed way to write it, but really that's giving you 2 separate solutions. And if there's not a square root stuck in your answer, you should go further. So we can do 6 plus 2, and we can do 6 minus 2, and we can actually say what that is. So my solutions are 8 or 4. 4, go pen, go. Don't give up on me now. There it is. So A is equal to 4 or 8. Remember with quadratic, we're not doing anything that introduces extra solutions. That would be multiplying both sides by something with a variable, or squaring both sides is similar. So we're not going to have extraneous, but it is good to check. So you can run those back through just to make sure you didn't make a mistake. Okay, just one more of these. It's similar, so this would be a great time to maybe pause and try this one yourself. See if you can spot that simpler problem in that blurry mess that I just made. And then come back and check in with me. So I'm seeing once again that I have p plus 1 squareds on both sides. So as much as they look messy, those are like terms. I think I'm going to move the same way as before. I'm going to add a p plus 1 squared and move those to the left. So if you have 2 p plus 1 squareds and you add 1, you're going to end up with 3 p plus 1 squareds. On the right, we have a negative 8, but no more p plus 1s. So this actually fairly quickly turned into one of your variable on one side of the equation. So if I start at p, I'm adding 1, I'm squaring, I'm multiplying by 3, and then I'm adding 10, which means the first to go is the 10, and we will subtract to undo addition. So we get 3 times p plus 1 squared is equal to negative 18. The next thing I need to do is divide by 3. So p plus 1 squared is equal to negative 6. And I'm starting to get a little bit worried because when I square things, they should not end up being negative. But even if you're just kind of on autopilot and you haven't noticed, I would say now I'm adding 1 to p and then squaring. So to solve, I need to take the square root of both sides. And you can't just move that minus out in front. That really does give you plus or minus the square root of negative 6. There is a really cool branch of math you can go off into where you would use imaginary numbers in this case, and you get this whole complex number system that you can work with. But we're not doing that in this class. We are exclusively working with real numbers. So at any point when you realize that you're getting a non-real mess out of this, you can stop and say, this doesn't have any answers. No solutions. If you want to be really specific, it's no real solutions. But for our purposes, I think no solutions is great. So just a reminder that aside from getting extraneous solutions for rational and radical equations, you can also just not be able to get a solution for any type of equation. Thanks for watching.